In the previous lesson, we learned that many economic variables remember their past. GDP growth, inflation, unemployment, and interest rates often change gradually rather than randomly. Today, we shall measure this persistence numerically. The statistic that measures the relationship between a variable and its own lagged values is called the sample autocorrelation coefficient. To understand the calculation, let us simulate annual GDP growth for an imaginary economy over 20 years. The data are generated so that each year's growth partly depends on the previous year's growth. Notice that neighboring observations are similar. This gradual movement suggests positive autocorrelation. But how can we measure it? Autocorrelation compares a time series with a delayed version of itself. This delay is called a lag. We begin with the simulated GDP growth data for our economy. Each row represents 1 year's GDP growth rate, arranged in chronological order. To construct a Lag-1 series, we shift the data by one period. Each year's GDP growth is paired with the GDP growth from the previous year. The highlighted columns show these Lag-1 pairs. Every row now represents a pair of observations separated by one period.
Notice that every current observation is matched with the observation immediately before it. These pairs will be used to calculate the Lag-1 sample autocorrelation coefficient. If today's GDP growth tends to resemble yesterday's GDP growth, the Lag-1 autocorrelation will be positive. For Lag-2, we compare each observation with the value recorded 2 periods earlier. The same procedure is followed, except that the observations are now separated by 2 time periods. Comparing the two tables makes the idea of a lag clear. Lag-1 compares consecutive observations, while Lag-2 compares observations that are 2 periods apart. Higher order lags are constructed in exactly the same way. A convenient way to visualize autocorrelation is to draw a scatter plot. Each point compares GDP today with GDP 1 year earlier. If the points lie close to an upward sloping straight line, autocorrelation is strong and positive. The upward trend indicates that larger values tend to follow larger values, while smaller values tend to follow smaller values. This is exactly the behavior expected under positive autocorrelation. The Lag-1 sample autocorrelation coefficient measures the relationship between each observation and its immediately preceding observation. It is obtained by dividing the sum of the products of their deviations from the mean by the total variation in the series. Here, x bar denotes the sample mean. The Lag-1 sample autocorrelation coefficient is simply the correlation between the series and its lagged version. Its formula closely resembles the ordinary correlation coefficient. The numerator measures how current and previous observations move together. The denominator standardizes the statistic, ensuring that the autocorrelation coefficient always lies between -1 and +1.
The Lag-1 sample autocorrelation is 0.724. This is a strong positive value, indicating that GDP growth tends to remain similar from one year to the next. High growth years are usually followed by relatively high growth years, while low growth years are usually followed by relatively low growth years. The series therefore exhibits substantial persistence over time. More generally, the value of the autocorrelation coefficient summarizes the degree of persistence in a time series. A value close to +1 indicates strong positive persistence. A value close to 0 indicates little or no relationship between successive observations. A value close to -1 indicates strong negative persistence, where high values tend to be followed by low values, and low values tend to be followed by high values. Autocorrelation is an important tool in econometrics because it helps economists identify persistence, build forecasting models, and diagnose the behavior of time series data. In this lesson, we introduced the sample autocorrelation coefficient. We learned that it is simply the correlation between a variable and its lagged values. Using simulated GDP growth data, we created lagged observations, visualized them with a scatter plot, and computed the Lag-1 autocorrelation step by step. In the next lesson, we shall extend this idea to higher order autocorrelations and construct the correlogram, one of the most widely used graphical tools in time series econometrics.